Okay, so walk in and then we'll and then for your test and everything. So this is your test. So today we're gonna go over the last section, 5.5. We did 9.1 on last week. So 5.5. Before we continue with 5.5, anyone has any homework questions for me? Anyone have any questions for me? 5, 4, 5, 5, and 9.1. These three sections is due on Tuesday, tomorrow by midnight. So usually homework is due on Wednesday, but this is due on Tuesday due to your tests on Wednesday. So this is due on Tuesday, tomorrow by midnight. Anyone have any questions for me before we starting 5.5 here? Anyone? Okay. So far, the formulas that you guys need to learn, there are two formulas. One is PERT, P-E-R-T, and the other one is the compound interest formula, the A equals to P1 plus RON times to the power of NT. That is two formulas that you guys don't learn. So in this section 5.5, we add a couple more formulas. So we are talking about exponential and log models in this section. And when I talk about log models, it means that word problems, okay? So these are all the word problems here. So there are 5 commonly log and exponents functions that we will use in this class. The exponential growth, the exponential decay model, the Gaussian, the logistic growth, and the log models. So I can tell you that class, we will concentrate more on the first and the second one, okay? So these are the two that you will see in my test, is first and second one. We don't use the Gaussian model, the log model, and the logistic growth and the log model. So the Gaussian model that you see here is used in statistic class. This is used in what we call as a normal distribution. This is, you learn this in your stats class, so that's why we're not going to cover it much. The logistic growth model is used for like the demand equations that you guys did in 5.4. That is a demand and demand equations that you see on this. This is called a logistic growth model. So again, we are not concentrate too much on this this formula. And then the log models is used like measuring intensity of a light. So as you know, guys know that when you have a light, when you slowly move the light source away from the surface, the light source is getting much it cover more spaces, but the intense it's not that good because you know you're further away from the source. But if you go a bit lower, you find out that the intensity is very high, but then you only cover small spaces. We use number 5 log models to do that. pH. So you guys know what's pH, right? Like in your chemistry, you learn your pH. You know, water is on around 7. You know, acid, alkali. So pH is also using log models. What else is using log models? Earthquake. So how we measure earthquake is all using log models. That means it's go from 1 till 10. If you look at the earthquake in Richter scales, 1 means it's really light, 10 is really crazy. So 7, 8 is going to be considered crazy, really, really bad. So that is you use that a lot in log models. Is mostly around this the light, the pH, the earthquake. Now, because those 3 we're not doing too much of it, but we are concentrating much on the exponential growth and decay. So exponential growth is used a lot for example will be like money, like interest. Okay, so when you talk about interest formula, we always think about exponential growth. What else is in exponential growth besides interest? Bacteria. So our bacteria's population, so those are all going to be exponential growth. Means that we start very small and then it slowly goes really up really quickly. So slowly. So those are what we call exponential growth. Type of word problems. For exponential decay will be half-life. So this is a big one. Half-life means that it's talking about half-life of radioactive. So you cut into half by every year, every half-life years, depends on the radioactive. and then you keep on cutting half. So this means it's exponential decay. Medicine in your system. So so if you take like a ibuprofen or anything, the medicine is getting slowly weaker and weaker against time. So this is called exponentially decay model. So so again, we're concentrating on those two. So a lot of students needs to get confused between this. How do we know it's a growth and decay model? Is looking at your B. If your B is positive, is growth. If your B is negative, is decay. So you can always compare this growth or decay model with your PERT. A equals to PERT. Remember the PERT formula. Okay. So why I want you guys to know the PERT formula is because it is similar to here. So some of you will ask me what is AEBX stands for. So if you look at Y here, Y in this case is the same thing as A. So in this case, you will say Y in this case is A. A is your final amount. So this will be your final value here. So Y in this case is your final value, means that that is your last, your final, what is the value at the end after a certain time. If you look at A in this case, if you compare to PERT, A in this case is the same thing as P, which is principal. Principal in this case is your initial value, means where the value is starting. So so we just change it to instead of A and P, we use Y and A. B in this case, if you look at your PERT, B in this case is the power, so it's rate. So B in this case is actually your rate, and X in this case, if you compare this with the formula, is your time. Okay. So I just want to point out to you guys that a lot of the formula using is where Y equals to AE to the power of BX or AE to the power of negative BX. I would strongly suggest you to just use that PERT. Just just a different values here. Okay. So actually, the formula is similar to PERT, so you do not need to worry about memorizing another formula, another two more formulas on top of PERT. So make sure you guys know that if you see this formula comes up, means Y is your A, which is your initial final values. A in this case, which is your principal, which is your initial value. B that you see here is the same as your rate, and X in this case is your time. So if you compare it to PERT, it's very similar. Anyone have any questions with this this formula for the exponential growth and decay model? Anyone? And yes, either you memorize PERT or you memorize this formula. I think since you guys know PERT, so I would recommend you to use PERT. Let's take a look at the first question here. The first question in this case is asking us to determine what is the principal. P, if you invest in 5% that compound monthly, so that 500,000 will be available in time for 10 years. So this question, 5.5, question number 1, is talking about compounded monthly. So this is not exponential growth, it's not exponential decay models that you see here. Since it's a compound monthly, you have to use the formula of A equals to P 1 plus R over N to the power of NT. So this is the formula we're going to use here. So I want you guys to go ahead, read question 1 and figure out what is given to us. So we need to find P. This is what you figure out. So usually they give you everything, the A, the R, the N, and the T. So read this question. Gamal, what is your A in this case?
500,000.
R is the rate, so the rate is 5%, so you have to change it into decimals, 0.05. Anyone know what is N in this case? N?
It's the compounded monthly.
Monthly. So monthly means how many months in the year?
12.
So that will be your N, 12. And the time is 10 years. Okay, it's given us 10 years. So plug all this into your formula here, and you have to solve for P. So 500,000 is your A. 50123. P is, I didn't know, we need to find P. 1 plus R. R is your rate, 5%, 0.05. Over 12 to the power of NT. NT is 12 times 10. And we know 12 times 10 is 120. N times T is 12 times 10. So I want you guys to take out your calculator and calculate this whole thing. And again, you cannot round your answer here. So take out your calculator, class. Figure out your, what is this is. I'm correct, so you guys don't see my answer. Nukin, what you get for this?
I got 303,580.
No, the P.
Yeah. P.
Okay, so I'm calculating this one first. You get 1.6.
Oh, okay. Yeah.
Fine.
Sorry.
Yep,
Yeah, I got 1.6. Oopsies.
You're fine. You're fine. Don't worry about that.
Sorry about that.
So on, so on, so on. And then after that, you have to divide this with him, right?
Yeah.
And if you guys did this, you can use your ANS button. So you don't have to type all these decimals in there. And yes, you cannot round. This is the one that a lot of students get wrong in your homework. It's because they round to 1.647. You have to type in all the decimal place in here. And again, Nuki, one more time, what you get here?
I got 303,580.
300.
303,000.
3,300. 330.
303.
303.
And then 580 at 303, 580.
580.
Yep,
Point something.
0.5202.
So 52. So now you can round this because it is your last, your final answer. You guys doing all right here with this? Yep, 3035. Yep, that's correct. Questions with the first questions here. All right. Question 2. Determine the time for P dollars to double when it invests for 10% that compound continuously. Does anyone know a shortcut to do question 2? That you need to double the amount with a rate of 10% that compound continuously. Anyone know a shortcut here? This is learned in 5.4, which is this fellow. If you remember that. Anyone know a shortcut for number 2?
Isn't it too natural?
Yep, ln2 over by what? The rate, which is 0.1. Okay, so the 2 comes from the doubling, so ln2 and then over by the rate 10%, 0.1. So if a question is asking for compound continuously that you need to double with a 10% rate, this is the formula. Anyone has a calculator to help me with this? This is the quickest way to do it.
$6.93147.
So close to 7 years, so 6.93 years. Don't forget, this is talking about time, so time is obviously in years. And if they ask for P is the principal, is always in dollars. So make sure you guys know that P is dollars, and and time is years in this case, the unit. You guys all right with, this is not too difficult, right? This is a difficult part is number 3. So please pay attention for number 3. Please pay attention. This is in your test. Okay. So find the initial quantity of plutonium-239 if the half-life is 24,100 years and the amount after 1,000 years is 0.4 gram. So this is half-life. So when we talk about half-life, it's a decay function. So the formula that we use is, because this half-life is decay, is y equals to AE negative BX. Due to the rate that we use here is negative. So actually the model that we use is similar to the PERT. So I want to point out to you guys that when you guys do the, I know it's a half-life, the rate is negative, we are still using PERT in this case, but instead of money, this is about how much is it, the grams, okay? So if a question is asking for initial amount, so which one of this is your initial amount? Your A, your P, your R, or your T? So, I'm sorry?
A.
A is your final amount. So don't forget, A is your final amount. So your PERT P in this case is your initial amount. So if a question is asking for initial, so this is the one that you need to find, the P. Okay, and A, same thing. See, this is tough. When I change it, everything, everything changed, right? So what is A in this case then? What is your final amount? The final amount in this case will be 0.4 grams. Okay, the rate and the time. Now we know the time is 1,000 years. That is because it could take 1,000 years to go 0.4 grams. Now the rate is the one that I want you to point out. This is very important. So every time when you do a half-life, the formula to find rate is always ln of 0.5 over by the half-life years. So this is fixed. Okay, so this is just for half-life, not for the interest, the compound interest or compound monthly, all those things. This is just for half-life. So this is fixed. So please make sure you guys know this. So in order for us to find rate, it's ln 0.5. The reason why we use 0.5 is because it's half over by the half-life years. So for this case, your rate is ln 0.5 divided by 24,100. This is the half-life year for plutonium-239. Okay, so what we do here is we plug all this into this formula and try to solve for P. So A in this case is 0.4, P is P, E to the rate in this case is ln 0.5 over by 24,100 times 1,000. Okay, you don't put a negative here. The reason why I don't want you guys to put a negative in there is because this value that if you use your calculator, this value is automatically negative. So every time when you do this value is automatically negative. So if you put another negative up front, two negative become positive. It's no longer a decay function. It's going to be a growth function. So that's the reason why that when you guys do the decay functions, you do not need to put a negative in the R. It's because this formula that we find the R, the rate, the half-life, is already automatically negative. And the 0.5 is the one that makes it negative. Okay. So what you need to do, class, is take out your calculator and punch this one out, e to the power of L this. Okay, go ahead, take it out, class. And then after that, you divide, use that divide by answer, divide by 0.4 with the answer. So go ahead and do that. 0.5, this is 0.5, ln 0.5. Oops, sorry. And you're gonna do one more questions for me. That's my E. No. Oh, I need to type the whole thing back. I don't like my calculator. Anyone got an answer here? This is 0.97 something. 16. And then you divide by your answer. Anyone got an answer here? Your answer should be 0.4117.
I'm getting a different number when I do the rate.
What do you get when you type this e to the power of? Make sure it's ln 0.5 over by 24,100. Come on, what you get? I don't know how you do it because I cannot see.
I didn't put it to E. I think that's why.
Yep, you need e to the power.
Required.
Yep, you need e power of it.
Should I take the negative out when I do that?
It will, no, do not. Just type in, leave it as, so type e to the power of ln over this times that. Class, please take out your calculator and start punching, because if you don't do it in your test, you will lose 5 points easily. This is 5 points in your test. Who didn't get it beside Gamal?
So I got 0.99999712391.
Yeah, me too.
Maybe I type it wrongly. I'm not going to using this calculator because this is I think this is correct. Yes, that. Let me take out my calculator. That calculator is that. Oh, that one. Make sure you have a night that. Make sure you put e to the power of something. Ln of 0.5 divided by 24100 times 1000. No, it's 0. This is correct. Yeah, everyone's so in your calculator you hit e power, right? Make sure you have your it's automatic parentheses, right?
Yep.
And then you type ln, you have automatic parentheses, right?
Yep.
You type 0.5 and what you do?
Parentheses and then divide by 24.
Divided by 24,100.
Yep.
And then times what? 1000.
Yep.
You get 0.9716, so on.
No, I got 999.9712.
I was getting that number, but once I did all of that as one equation instead of stopping at the divided by 24,000.
Yeah,
and then multiplying by 1,000.
You have to type this in one whole string in your calculator. You're correct, Gamal. Yep. So Calvin, can you try it again? Type in one whole string. Don't. Henry, Andrew, Andy, Avery. You guys got this? This is 0.9716.
Yeah, I got that. I was having a little bit of trouble, but I got it.
Okay, good.
Yeah,
Okay,
I
Henry
was-
got it.
I was having the same problem until, because I was putting a parenthesis after the 24,000.
Yep, no
100.
parentheses.
Yeah, me
Yep.
too. Yeah.
Yep,
Yeah.
don't put, so some of you who put parentheses over here, no good. Okay, so don't put a parenthesis around. You guys got 0.9, Calvin, you got 0.9716 now?
Oh, okay, so I see what I did wrong. So yeah, you're supposed to add the 1,000 in the power too, right?
Yes,
okay,
everything is, this whole thing is all in the power.
Okay, so that's where I got it wrong, because like I put I moved it over and then
Yep,
I timed the whole
I know
thing.
what you mean, like what Nukin just said, yep. And then after that, you take 0.4 divided by ANS. Once you get the 0.9716, you take 0.4 divided by the number that you have. You get 0.4117. You guys good?
Yep, got it.
So you guys, because this is in your test, that's why I want you guys to, everyone know how to do it. Okay, since you guys say, oh, I got it. Okay, so I want to look at, you can do your homework here because they are the same. This will be the one. Oh, nope, sorry. This one. This is carbon 14. The half-life is this. The initial quantity is this. Find the amount after 1,000 years. Yes. So it's very similar to question number 3 that we did here. Can move things around here. So I want you guys to go ahead and do number 8. Question number 8 for this homework. That's your homework. The half-life is this. Half-life is this. This is your initial quantity, and this is your final amount in 1,000 years. So for this question, you need to change things a little bit around. So go ahead and try it. Question 8 is easy, actually. Does anyone know this 28.5? What is that? A? Is that P? Or is that R? Or is that T?
A
So no, that's not your A.
P, right?
and P, sorry.
Initial quantity is always P. P is 28.5. And what is your R in this case?
ln 0.5 divided by 5,715.
Yep. And your time?
1,000.
1,000. 1,000. So this question is asking for what?
For
For A. Okay. So plug it into this formula. Go ahead, plug all this into this formula. And the good news is you do not need to do division. Yep. Please try this in your calculator. And I want it in 2 decimal place. Please, everyone, try this. Make sure you close your parentheses at the very end. Remember, I showed the one that we just did. Anyone got an answer?
Is it 0.8857809481?
You still need to multiply by, no. You need to plug 28. P is, we doesn't know this. So it's 28.5 times e to the power of the r, all this icky stuff, times 1000, right?
Okay.
I got 25.24.
25.24. This is very calculator based, so make sure you guys use your this is very heavy on calculators. Same thing in your test. Avery, are you okay? Avery?
Yeah, I got 25.25.
25. Should be 2447. Should be 24. 25.24.
Oh, 24. Okay.
Yep, because of
Gotcha.
voice. Yep. Nukin, you get who? Is that Nukin? You got this one?
Yeah.
Gamal, you guys okay here?
Yep.
Okay, so be careful with the question, is because sometimes the question can ask you for the final amount, like question 8, and sometimes the question can ask you for initial amount, like question 3, like what we just do. So read the question really carefully, which one they want. So I want you guys to try question number 20 now. This is 20. And the reason why is it's in your test again. So make sure you know which one is which. Go ahead and try number 20 now. So on question 20, this 1 gram that you see, is that A or is that P?
A.
Let me repeat. This 1 gram, is that A, final amount, or P, initial amount?
A.
A, this is A. The initial amount is what you need to find. Okay, class, make sure you read the question really carefully here. So on question number 20, A in this case will be 1 gram. What is your rate in this case? Ln 0.5 over by what?
1599.
Okay, and the time is
4,000 years.
4,000 years. So again, plug this and you need to find P. Go ahead. Everyone try it. I'm worried because this is what your test looks like. And I want 2 decimal places. Anyone?
I got 0.8.
2 decimal place. Is that really exactly 0.8? 0?
Yeah, it was 7.995 for me.
So someone say this is 0.8.
I got 5.56 grams.
Point what? Gamma?
5.56.
Oh, cannot be 5.56. You know, it cannot be five. Okay, someone say 5.56. Okay, I'm just now we got a couple answers now. See, I'm worried about this is where a lot of students make mistakes is because of calculators. Does anyone calculate this icky stuff?
Yeah, I got 0.17658.
0.17 what?
Yeah, that's what I got.
5. Calvin, can you say again? 0.175 what?
1.176585227.
0.16585, something like that.
Yep.
Gamal, do you got that?
Yep.
Up, that's correct. And then after that, you have to take 1 over it, right? Because your A is 1, so you divide it. So what's 1 over that? 1 over your A and S.
5.6629888017.
So it's not this, so it's 5.66, right?
Yep.
So your answer in this case will be 5.66. You guys with me here?
Yep.
Mostly it's all calculator stuff, so make sure you guys know how to use your calculator to do this work. Same thing in your test. The formula is still PERT. You just need to figure out which one is which. Question. Yep.
So even when it's a decay model, we don't want to plug in the negative for the.
Yep. You don't need to, the reason why is because if you calculate this out, the rate, if you calculate the rate, ln 0.5 divided by 1599, what you get?
A negative number.
A negative number. Yes, you will get a negative 0.000433, so on. So if you put a negative inside here, it will change to become a decay. It's not a decay anymore. It will become a growth. You know what I'm saying? Because the negative times the negative make it positive. So that's why we will ignore the negative here. The reason why is because the rate is already negative in this case. You know what I'm saying? I'm Kelvin. Yep. So yep, that's the reason why that this is going to be you do not put a negative in front of it. Questions?
I don't know how you guys got that. I'm putting it down, but I'm still not getting the answer. Maybe I'm putting it down wrong?
You might need to show me what you type in your calculator. Do you get 0.176585?
No.
Okay, so can you show me what you put in your calculator? Because I need to see it. Otherwise, you had to
I
enable.
have a handheld calculator, so.
Yep, handheld. Yeah.
Oh,
You had to
okay,
enable
I
your.
guess. Yeah. All right, let's see. Right here.
You might need to
can't.
enable. Don't. It's blur. I cannot see. Can you
Yeah.
enable your the background, not making it
Yeah.
blur?
Yeah.
Because if you make your background blur,
You can't see it.
Yeah. And can you just show your background is blurred? That's why.
Yeah. Right here.
Who didn't get it beside Mukin? Because this is.
I'm good now.
Okay. Change your background so I can see your back. Yeah. Okay. Can you move a little bit towards the right? Yeah, that's good. Yep. Can you go towards the last because I cannot see that. Give me a sec.
So it's e to the power of ln, and it's the 0.5 divided by.
Okay, you need to close your parentheses. Okay, this is what you're missing here. You're missing a closing parenthesis. So when you do e to the power of ln, right?
Yeah.
0.5, you need to close your parentheses here.
Oh, okay. That's
Because
fine.
this is your ln only goes for 0.5. So if you didn't close your parentheses, they will do everything first and then ln.
Got it.
So
All
we're
right.
gonna do ln first, then the rest of it.
Ah, yes, I got it.
Okay, so make sure. So what I can tell you is watch your parentheses, closing and opening. So you do have a close right over here and then do this. You got it now, Nukin?
Yep. Yeah.
No, and then one over it. Anyone? I'm doing this because giving a test. I mean, I've been telling you which. All right. So we're gonna talk about question 4 here in your notes here. Question 4 is given us 2 points, 0, 5, and 4, 1. And they want you to find the exponential model for this case. That means they want you to find this model. So first thing first is you need to graph these 2 points. The reason why I want you guys to graph these 2 points to figure out are they exponential growth or are they exponential decay. Okay. So this is 0, 5. 4, 1 is right here. 4, 1 is right here. So can someone tell me, looking at these 2 coordinates point, are they growing or are they decaying?
Decay.
This is a decay because the graph goes down. So the formula that we use is you have to put a negative here. So the reason why that this one you need a negative and this one you don't need a negative when you do the half-life is because the rate that I mentioned early on here is already negative, so you do not need it. But this is not half-life model. This is not talking about half-life, and this is just giving you 2 points. So the negative is needed here. So that's why you need to know the difference. When do we need to put a negative for decay, and when do we not to put a negative for decay? So only half-life, we don't put a negative here. You guys got what I'm saying here?
Yep.
All right. The first point 0, 5, which is this one, this 0, 5 is what we call as your initial point. So that means that your P in this case is 5. So usually when you guys do this in your homework or your test, they always give you the 0 something. That 0 something is your initial point where it starts. That's your P. Okay. So we need to figure out rate so we can find 4, 1. So if you draw this used to be X and Y, right? But if you look at this equation, the Y in this case is actually your A. And your X in this case is your T. This is your time. So now if you look at this 4, 1, 4 in this case is your T. So your T in this case is 4, while your A in this case is 1. So this point used to be XY. If you use this equation that we have on top, then yes, you can use your XY point because that is your XY. But if you want to use PERT, then make sure that this is the A is your Y and your T is your X. Okay. So now what we need to do here is plug all this P and T and A into this equation and find R. Okay. So go ahead and do this in your calculator, plug all this into this equation and find R. So what's the first thing when you want to solve for R here? Anyone? What do you do first? Andrew, what do you do?
5.
Divide by 5. Yep. What's the next thing once you get rid of the 5?
Do you
R in
take-
front of the E.
So move the E, and what happens when you move the E over?
ln.
Ln, yes. So this Ln will be just on 1/5. So watch out for this, especially Lukim. When you put in your calculator, make sure you close your parentheses here. like what we over here. Don't forget to close your parentheses. And how do we get rid of the -4 since we got R here?
Divide by 4.
-4. So use your calculator and figure out what is this number is.
Why does it become negative if we're dividing by it?
We are dividing. So this is like, solving. We just need to divide by negative number. Come on. It has a negative here
Okay, I got you.
because it's a decay function. Okay, that's why the negative is.
I got 0.402359471.
.4034. Positive 0.4023 something, 24. You get this? 0.40235 like that. And the R is positive here is because we use negative. So the answer, you just need to change it. So I think your online homework doesn't like you to use PERT. So they want you to use the Y and X. So you just change your A to become Y. So your answer in this case will be Y equals to, what is your P here? P is the initial amount, which is 5. E to the negative of this, 0.4024x. So instead of using PERT, we just change it back to Y and X. I think because it's an equation, and equations always have Y and X. So you just change it back using that. And that is your answer for question 4. You guys all right? All right, questions for me? I want you guys to try to do number 9 now. Number 9. This is number 9. 2 points. Is that growth or decay for number 9 here?
Growth.
It's growth. So we're gonna use this. And don't forget that A is always Y and T is always X. So go ahead and try to do number 9 here. You guys good? You guys talk among yourself. Talk. You guys are quiet. Talk among yourself. You guys are quiet. Go talk among yourself. How you? I think it's 3-5. Yeah, 3-5.
I got 1.0729586808.
For what? The rate?
Oh no, yeah, for the rate, yeah.
1 point something? Kevin, can you say that again? 1 point something?
1.0729586808. Because your P is 1/5, right? And then your T is 3, your A is 5.
That is correct.
So your equation will be 5 equals 1/5 ER3. And you divide by 1/5 on the other side.
Instead of divided by 1/5, it's a someone.
Time.
Yeah, so this is actually is times 5. So don't divide it, multiply it. You can, but it's so what you get here is what? 25. And then like last time we moved the E over, become what?
ln 25,
And then divide by what?
3.
3. Because the 3 here. So this is your rate. And when you use your calculator, you guys got this? Divided by, oh, no, sorry. No. So ln 25 divided by 3. Yep, that is correct. So what is your answer in this case? In how many decimal place do he needs? In 4 decimal place.
Would be
In
y,
4 decimal place.
y equals 5.
1/5. E to the
That long number.
positive or negative?
Positive because it's growth.
In 4 decimal place is 1.073, right?
Yep.
X. So this is your answer in this case. You guys okay here? Questions? Right. You guys are super quiet here. Next one we talk about is number 5. So question 5, this is very similar to your homework also and your test. The population P in thousand of Tallahassee from 2000 to 2010 can be modeled at this model where T represent the year since 2000. So that means T equals to 0 means year 2000. So in 2006, the population of Tallahassee was 347,000 people. Find the value of K. Is this increasing or decreasing? Explain. So find K first. Explanation is very easy. So can someone tell me that in 2006, what is the time?
6.
6. And it's the population is 34700. So that is your P, right? The population is P. So can you write P in this case is 34700? Is this correct? Pay attention here because this is in your homework and test. Can you write 34700 for your P? No.
No.
So Kevin, why we cannot write 34700 as a P?
You have to write 347.0.
So the reason why is because that the P is in thousand here. So this, if you put this, means you represent 347 million people. So you actually have to drop the 3 zeros behind. Okay, so that's the reason why that when you do your homework, it's wrong, is because a lot of students they put 3470 in here. So go ahead, plug this into this equation. P equals to 319.2 EKT. And try to solve for K here. That's what the first question is asking for. So 347. $6K. Anyone find K?
Zero point zero eight three five zero six.
835.
Yep. 0691432. Yeah, that's a long.
No, I know. It's a lot. Yep. Kelvin got it. Anyone? Besides Kelvin? Because he's not the one only doing a test on Wednesday. You guys all have to do it. Andrew?
Yeah, I got that number, but I got that before I divided by 6, like,
Hmm?
or, I don't know, I did, 347 divided by 319. And then ln times, it was 1.087774.295. So I
And
did
then what
L,
you do?
I
Do you
did
divide by
ln
6?
that. I didn't get to that yet. I did ln that number 1.08, and I
Oh,
got,
you no. You read out and it. So you just so Andrew and the rest, when you guys do this, you type it at the very when you use your calculator, you use it very end. So you just
okay.
do so you don't type like this divided by this and then ln and so on. So you just do this at one shot using your calculator. And then the next thing you need to do, so you have to divide this by 6, right? So this is what you enter in your calculator in one shot. And make sure you're closing your parentheses right after you finish to dividing 319.2. Yep, all of you please practice this. It's mostly a calculator. So make sure you close the 319.2.
You'll get 0.0139.
Yep, so this is actually wrong, Calvin. This is wrong. 0.013916, something like that.
Yeah, that's the number you get when you do ln 347 divided by 319.
Okay, before divide by 6.
Yes.
Okay, sorry. So make sure you I'm going again, I'm going to tell you guys right now that when you do this in your test, make sure you just do all the division and all the ln, everything, so it's K is by itself. So that's why I'm asking for K.
Oh, I thought you were.
So the question is asking for the K. You guys all right here? Questions. So now the question is this K increasing, population is increasing or decreasing? K is your rate.
Increasing, right? I mean, it would be negative if it.
Yep. So in this case, this is increasing because your K is what?
Positive.
Positive. Yep. So again, it's like growth and decay. That's what I mean by increasing and decreasing for the population. Part B is asking us, you guys all right so far? According to the model, during what year the population reached 410,000? So the model now, if I put this back here, this is the model, is P equals to 319.2 e to the power of this 0.013917 t. All these numbers that you have. Okay. Oh, I just put A and S because that's your previous answer, this one. So now the question B is asking for what year is this when you reach 41? So this 410,000 is your P. So we will put 410 without the thousands again, because your P is in thousands. And then 319.2 e to the answer t, because answer means all is equal. This is your answer. So how do we solve for t here is we divide this by 319.2. And then the e you move over, become ln. And don't forget, when you do ln, it open the parenthesis here and it close the parenthesis there. Okay, same thing with your calculator. And then you divide this with your answer. Means this 0.0137, 13917, all these equidecimals. You get a t here. So go ahead and try this now. I think you guys have an ANS in your calculator button, right? Anyone got an answer?
I got 17.98.
Yep, so it's very close to 18, right?
Yep.
Very close, guys. If in your online homework, if you type 18, they will mark you wrong because that is not the year, that is the time. So what year is this?
2018.
Yep, so this is 2018. So make sure you guys careful when you put it in your homework here, because that is not 18, is not your final answer. The question wants it in years, not in the time. Questions? Anyone? Questions for me? All right. You guys good here with this one? Do number 6 here. So a piece of ancient charcoal contains 15% as much radioactive carbon as a piece of modern charcoal. How long ago was the tree burned to make an ancient charcoal, assuming that the half-life of carbon-14 is 5715? So this question is very similar to your double, triple, your formula for compound interest, compound continuously, that is double, triple, and so on, right? So remember last time when I say for double, what do you do with your formula to find the time?
0.5.
So we take ln of 2 divided by the rate, right? And if I want triple, I just do ln 3 divided by rate. So for this question, you want to find the time. It's going to be ln. Now, it's not 0.5. Is the how much left over. So this question has a 15% left over. So it's going to be 0.15. Okay. So so this 15% will be on the ln. Do you guys know how to find the rate for a half-life? What is the formula to find rate?
ln 0.5 divided by the half-life.
The years, right? So what you do in this case is, this is ln 0.5, 1.15, because it's a 15% left, over by ln 0.5, that's a rate, over by the year. What's the year is? 5,715. Now, when you put this in your calculator, you need an extra parenthesis here. Okay, and the reason why is because you tell your calculator to perform this first before you divide that on top. So if you don't put a parenthesis on the extra parenthesis on the bottom here, they do the ln 0.5, 1.15 with that divided by n 0.5 first, and then they divide by 5,715, which is wrong. So make sure you do the parenthesis in this case, the orange one. So go ahead. There's a lot of parentheses here, so be careful with it. Take out your calculator and try to do this. And watch with what you type in your calculator.
Is it 15,641.75?
15,641.76. You guys all right? Anyone got this? Everyone do not get this? That's the main part. Who did not get this one? I'm gonna take attendance now. Go ahead in the chat room, type present. So this is how we do. So if you want to be an archaeologist and you figure out how old is this dinosaur bone or how old is this thing is, this is the formula you will use. You usually use carbon-14, and then usually this is a half-life of carbon-14. And what you do is you put like 1 gram of carbon-14 into the dinosaur bone or whatever you do, and then you mix it, and you figure out how much percent left from that 1 gram of your carbon. Let's say you only left with 15%, then that bone is around 15,000 years old. This is what they do to figure out how old is, an artifacts or archaeology dig site or whatever you do. So that's how they do it. Okay. Questions, anyone? Anyone have any questions? Now I'm going to do another question which is not in here because it's in your test. Okay, so this is not in here. So the rest, go ahead and do yourself. But this is mostly what I want to talk about. Is a test. It's a word problem. So let's say that you have a pair of rabbits. You start with a pair of rabbits, and they do their business. Then after, let's say 20 days, you found out this pair of rabbit, pair means 2, 1 male, 1 female. After 20 days, you get 10 rabbits. So my question is, how many rabbits in let's say, so 20, let's say 30, let's say 50 days. And this is exponentially growth. Okay. This is exponential growth part because we know that keep getting more. So you start out with a pair of rabbits, and then after 20 days, this pair of rabbits become 2 rabbits, become 10 rabbits. So my question is, how many rabbits do you have in 50 days? So this is what some of my students do in my test. Okay, so 20 days, 10 rabbits. So that means average is 2. So how much is 50 days? So you do 50 days X rabbit, right? Then you cross multiply here. So 20x equals to 500. And then divide by 20, x is, oh, we got 25 rabbits here. Is this correct?
No.
This is completely wrong. Why this is wrong? It's because this is not exponentially growth. This is what we call as linear growth. Linear growth means that one day you have this 2 rabbit, 2 days you got 4 rabbit, 3 days, so you double this. So we are not doing linear growth here. Linear growth means every day you only got 2, increase of 2, example, or divide by 2. So this is exponential growth. So don't do this in your test. You will get it wrong. So the first thing you need to know is how you find your rate. So by reading this question, we'll be using this formula, PERT, because it's a exponential growth. So when I say a pair of rabbit is what you start at, so that is your what?
P.
That's your P. So in this case, this means P is 2. 20 days is your what?
T.
The T, and 10 rabbits is your
A.
A. So I want you guys to plug all this into here and find your rate. You need to find rate first. So A is 10. P is 2, start with 2 rabbits. E to the 20T, 20R, sorry, because your time is 20 days. So you had to divide by 2 first. And then I'll end this. And then divide by 20. Anyone got rate in this case?
0.0804.
So it's LN5 because 10 divided by 2 is 5. Where's LN5? And then divided by 20, right? Yep, 0.08047, something like that. This is your ANS now. So I want you guys to figure out how many rabbits do we have after 50 days. So it's A equals to 2. We still have to start with 2 rabbits. E, this is your rate, ANS, good, times 50, because we are looking for 50 days. So how many rabbits do you have after 50 days?
One 111.803.
How many?
111.803.
So it's 111.8, so 112, right?
Yeah.
Can I have 111.803 rabbits?
Missing 11.
112? Right? Is that correct? Kelvin knows what he's doing. I'm worried about the rest of you, because you guys are really quiet.
Yeah, I got the same thing.
Okay. Again, I'm just round a little bit here, so my answer is a little bit off. Yep. Yeah, 112. I know you guys said 11.8 because I didn't use the whole R. You guys all right here? Okay. Questions for me before we're gonna review a little bit on your test because we got some time here. Anyone? So don't forget you got 3 homework due tomorrow, 5, 4, 5, 5, and 9, 1. So we're gonna do a little bit of review on your test. So the first, if you have a review test, this is a review test here. This is what the first question is. It's worth quite a lot of points, 11 points. So does anyone know how to do the first question, identifying the conic section here? Zip. Anyone remember how to do that?
The X is by itself and the Y by itself.
This is your review here. So you will separate your x's. So you got 9x squared minus 36x plus what? 25y squared minus 50y is equals to what? Negative 52, right? So yep, first thing is separate all your x, y, and numbers here. And then what you do? Let's concentrate on your x. Anyone beside Calvin? Because Calvin is giving me all the answers. Anyone to try this? What you do once you separate them out? What my formula here? Anyone? Gamal, Nukin, Andrew, Avery, what you do next? Henry?
You factor out the 9 from the x's and the 25 from the y's.
So you get x squared minus what?
4.
4x. Let's do the y, x first, and then we'll consider the y. What next? Yep, you're correct. Take out the 25 from the y. So
And you take the half of the middle.
and square it, right? So take the -4, half it, and square it. So what you get? This is 4. And what you need to do is you have to add 4 here. But what you need to add on this side?
36.
36, because 9 times 4 is 36. And this can be factored. And your factor in this case will be x minus 2 squared. The minus comes from this negative, and the 2 comes from the 4. We still have a 9 in front. So this is how we do the x part. We're going to do the same thing on the y part. So someone say take out 25. You're correct. What'd you get?
Squared minus 2.
And then you take the middle term, which is what? The -2, you take a square over 2 and square it. What you get? You get 1. But what do you need to add on here to balance your equations?
25.
25. Yep. Because you got the 25 there. So this will become 25, positive 25. Y minus, sorry, because there's a minus sign here, y minus 1 squared. And if you add all this and subtract 52, you get what? You will get 9. Okay, so this will give us 9 here. And then what you do next is divide everything by what? By 9. So this is exactly 1. So this will become x minus 2 squared over 1. Up to you to write the 1 or not. Plus, this is y minus 1 squared over what? (9 over 25). Because this 25, you can always put it down in the denominator, but then it will be over. So can someone tell me what kind of conic section is this? Circle, ellipse, hyperbola, parabola? And when you, again, class, this is very important in your test. If you tell me if it's ellipse or hyperbola or parabola, you have to tell me is that the major axis is horizontal, vertical, you know, which one is it? So how do we know if you look at your ellipse is to figure out which one is bigger? If if the A has to be greater than B, if your A is on the X, that is horizontal. If A is on the Y, it's vertical. So how do we figure this one out? Is figure out where is your A in this case. So which one is bigger, 1 or 9 over 25?
1.
So this will be your A squared. And this will be your B squared. Okay, those also depends who is bigger. This is for ellipse. So so what is it? Is that going to be a major axis on the horizontal or major axis going to be on the vertical? Which one, horizontal or vertical?
Horizontal.
This is horizontal, yep. Okay, so what is the, once you get this, you need to figure out what is your center, your center of your ellipse. So how do you figure out your center? Is HK, which is, this is your H, this is your K. So what is your center in this case? 2, 1, right?
Yeah.
And A in this case is what? Plus and minus 1. B in this case is what? Plus and minus 3/5, which is the square root of 9 and 25. And what is C in this case? You have to use the formula. What's the formula we use for ellipse? C squared is equals to what? A squared minus B squared. So this is something you need to know. It's not given in the test. So it's A squared minus B squared. C squared is. So A squared is 1 minus B squared is 9/25. Because 3 times square is 9/25. What is this going to be? 16/25. And you need to take the square root of it. So you have plus and minuses. C in this case will be what? Plus minus. You want? 4/5, right? So my next question is, so since this is a ellipse, you have to give me the center. If you got the center, you have to give me the vertices and the foci. So these are the things you need to give it to me, vertices and foci. If it's a hyperbola, you give me center, vertices, foci, and the asymptotes. If it's a parabola, you need vertex, focus, and directrix. If it's a circle, you need center and radius. So depends on what kind of conics that we have. Since it's ellipse, center, vertices, and foci. So in order for us to find the vertices, is using A. A is always vertices, and C is always the foci. So the formula is, if you have it on the horizontal axis means to go flat, means you add it on the first one. So it's plus minus H plus minus AK. If this is on the vertical axis, then the plus minus goes to the y value. So it depends on, is that vertical or horizontal. So you need to watch carefully with this. So since this is a horizontal, so it goes to that, to the x value. So H is 2. This is your HK here. So it's 2 plus minus 1. Your K is 1. So your answer is 3, 1, and 1, 1. So this is your vertex or vertices. Your foci or focus points is H plus minus CK, because again, it's a horizontal. This plus minus C is on the x value. So so it's 2 plus minus C is 4/5. Okay, 1. K is 1. So this will give me 2 plus 4/5 is 14/5. And then 2 minus 4/5 is 6/5. So this is your focus point in this case. And how do you draw your vertex, your ellipses? Is basing A and B. So usually, if you want to draw something, if it's ellipses or hyperbola, this too is what is needed, and definitely center is what we needed. So these are the important ones. The C is not important to draw. Foci is not important to draw. Only the vertices, the center, and the B. So you start out with 2, 1. That's your center. A is 1, so since you go horizontal, so you go 1 to the right and 1 to the left. So that is the A. And then B is 3, 5. 3, 5 means you go up, down. So up, so 3/5 is up and 3/5 is down. So you get this, and you get yourself a ellipsis here. Okay, so this is how you draw ellipse. And what happens if it's a hyperbola? A hyperbola is still gonna be the same thing, but this time you don't draw a ellipse, you draw me a box. Okay, so if it's a hyperbola, you draw me the box, and then you connect the box from the center to the one end. That is your asymptotes. And since your vertex is here, so it's open sideways. So this is your hyperbola. So the difference between ellipses and hyperbola is ellipses, that 4 points that you draw is going to be a circle ellipse. But for the 4 points that you have when you went for hyperbola, you need to draw me the box and then you draw me the asymptotes. So that's the only difference between how you draw your ellipse and your hyperbola. Okay, so this worth a lot of points, 11 points. So make sure you guys know how to do this in your test. The rest of this question, please make sure you understand how to do this. Mostly they are all from my notes. So make sure you practice this for your notes here. Anyone have any questions for me before we end our Zoom here? If you have no questions, you may go. If you have any questions, please do stay back and I can answer any questions you have. Anyone have any questions for me?
Yeah, I'm going to it right now. It's on one of the homeworks.
Okay, you got homework questions. Good. What sections and what?
I believe it was 5.3 or maybe 5. Yeah.
Do you know 5.3?
Yeah.
5.3 is due last Wednesday. Is that the last week homework?
No, my bad. It's 5.4. I'm sorry.
Okay. All right. So I'm just asking because 5.3 is due last week. So do you know what question is it?
It's loading right now. Yeah, it's question 14.
1-4.
14.
Yep, this one, right? Tell me what you have in yours because my one's different.
I have so 7 parentheses 3 to the power of 6 minus 3x.
Mm-hmm.
Close parentheses, and then plus 14 equals 49.
So what we do in this case is we have to solve for x here. So we have to get rid of the 14 and the 7 first.
Okay.
That's the first thing to do. Because we want to get him by itself.
Yeah, I know that far, so I know to take away 14 and then divide by 7.
So what do you get?
3 to the power of 6 minus 3x equals 5.
5, okay. And then now we move that 3 to this side, right? Is that how you do it? How do you do it? Tell me how you do it. And there's so many ways to do this actually.
Found it when I was doing it.
There are so many ways to do this. This is correct. This is correct. You start up with the correct.
Yeah, so I divided by 3.
You cannot divide by 3.
Because
this is exponents. If it's multiply, you divide by 7, you multiply, you divide by 7. That's correct. But this is exponents.
So then how would I do it?
You had to move this 3 back. Move your base. Because it's exponents, so you cannot divide by 3. So you get 6 minus 3x is equals to what?
Log 3/5.
Yeah. And then do you know how to use your calculator to figure out what log 3/5 is?
Yeah, it's log 5 divided by log 3.
Okay, we'll do that later on. Don't forget, we'll do that. You can say, yep, that's change your base. That's correct. How do we get x alone here? Now we get rid of these 2. The 6, what we do with him?
You're gonna move the 6 to the other side
So you minus 6,
and divide by 3.
divided by negative 3, right?
Divide by negative 3.
You got negative 3 there. So what you need to do here is take out your take out your calculator, do what is log 5 over by log 3. This is correct. And then whatever you get, minus 6, and then divided by negative 3.
Okay. I get
And you-
1.51.
How many decimal places you need?
Hmm?
How many decimal places there? Question once.
Oh,
3. You need 3.
wasn't it?
3 decimal place.
Okay.
1.5. You got it?
Yep.
I don't know what the third decimal place is. You got it, this one?
Yep.
So make sure you know that when you see a power here, you don't divide, you move the base.
Okay.
Okay. You divide when you got something like 7.
Okay. Is it always gonna be log?
Yep. If
Alright.
it's exponents, it's gonna be log.
All right.
If it's log, it's exponents. So multiply, we divide. Exponents, we log.
Okay. I got you.
Mhm.
What's it called? Earlier you were saying the other part of the first question from the test review was in your notes. Are those the like the pictures that you send us in our email?
Nope, you go to D2L. It's kind of yeah, it's kind of the same as that one, but the D2L have everything.
Okay.
So you go to D2L, you go to my class sections class, and then you go to materials right on the corner here, and then you go under content. You can also look at the notes, but this is better. And then you go to the instructor notes. And what section is that? 4.4, right? I think it's
Yeah.
question 5, I believe. So you go to 4.4. This is 4.3. So this is 4.4. Question 5 is this one. See that?
Yeah. Okay.
And then what's the next one? 4.4, question 7. Just go down.
It's okay. So
It's all
it
there.
says it on there. Yeah.
Yeah.
Okay.
This is
Nice.
question 7. 4.4. So it's right on the, if you look at your review, it's right next to the bold one.
Okay. Thank you.
Question 9, question 11. So yeah, just, yep, go to the D2L. It's better go do the D2L because it's all there.
All right.
You
Sounds
can
good.
easy to look at it. Question 9 is this one, and then question 11 is this one. And then the next is 5, I believe. So make sure you just look at it. Yep, the next is 5.4. If this question 6 is not in there.
Okay.
This one, I think we did it last Wednesday. So watch the D2L for last Wednesday. This one we
Okay.
did. Yep. The rest is all in my notes, in D2L notes. Yep.
I got you. Thank you.
Good. Any questions for me?
No, that's it. Thank you. You have a good day.
You too. See you on Wednesday.
See you Wednesday.
Bye-bye.